Hello everyone. Now we start on the JSON side of things. So as for the student class, you already know Lombok, so I'm gonna do a fresh start. Now, what is JSON? JSON stands for JavaScript Object Notation. This is how objects are depicted in JavaScript. So the real quick cheat sheet for JSON is curly braces. Oh yeah, by the way, JSON comments aren't like this. Actually, JSON doesn't have comments at all. So I'll just put comments there. Why not? So in JSON, the curly braces mean object and square brackets mean array. So an array can have multiple objects. So there can be I'll just show here. So we'll model this class. We have a student class with a name, a Neptune code, and a GPA. So we want to have a student in JSON. So in JSON, all the attributes and their values are strings and they're converted later on. So, right, strings as in they're written in double quotes. So, a student has a name and it's colon. You put the attribute name, colon, and then the value. Name Fahad, Neptune, and GPA. Even though GPA is a number, we still write the value in double quotes. So, we have an object in JSON. Now, what is the purpose of this library called Jackson? By the way, it's imported in the POM file. You can see Jackson data bind. Now, you might notice this word called bind. So, what does Jackson do? Since we won't be doing any binding ourselves in the exam, I won't focus on the binding part, like the specifics of how it works, but I will explain like how the mapping thing happens. So suppose you have a class on your in your Java, the student, and it has string name, and then in a separate file you have a JSON file, an object that has the fields, the name and a value. Because if you remember JavaScript, or if you have studied JavaScript, you know JavaScript doesn't have types, so they just has the name of the field, name, Neptune, GPA. So we have this file and we have our class. So what Jackson does is I'll show an implementation example first. So Jackson uses this thing called, you know, there's scanner, right? In Java, scanner's job is to take input from the console, the console or any other input source like a file. There's there's other objects as well, like a comparator. So you might have noticed that Java uses an object to do anything. If you want to compare stuff, it uses a comparator. If you want to print stuff, you want to scan stuff, there's scanner, and for printing, there's a printing library. So there should be an object to do this job as well. And true, this object is called an object mapper. So why is it called an object mapper? Let me just show you what it does first. Just create a new object mapper. Same way you would create a scanner. And then you do this. It has this value called read value. It has this method called read value. So what read value does is it reads a JSON file and it maps it to a class. So the class that we are dealing with right now is student. So we'll do object mapper dot read value. And what does this take? So read value takes two arguments. First one is the source, which I suppose would be new file because we are reading a file called input.json. The file path can be, I guess, source and resources and input.json. And the second is the class that we want to map it to. So right now we're dealing with the student. So student. And in Java, if you want to if you want to pass the class in as a parameter, you do dot class. And of course, read value, it throws the exception. So we'll just use sneaky throws, sneaky throws. So what this does is it sees that file, right? Input.json. It has these fields and it has this class. So it instantly does this. It sees that the input.json file has a field name with the name of name, and student has a field with the name of name. So it matches them up and it assigns this value to this field. It does the same with Neptune and it does the same with GPA. All it does is it sees that they have the same name. Okay, they're connected now. So this value from the JSON file, it gets assigned here, and same for Neptune. So in this case, it's mapping to a student value. We can just create a student container. Student is equal to, and whatever this is, we store it in a student object. Now we don't have a toString for it, right? Let's just create a toString real quick. ToString, and everything will be included in the toString, and we run main.java. Okay, this is where I always mess up. Cannot find the path specified. Oh, oh yeah, that's right. It goes source, main, then resources. So source, main, then resources. Now it should work. Okay, we're making progress. Just a second. Okay, let's check it out. It says unrecognized field name in the class student, not marked as ignorable. Zero known properties. Okay, here's the problem. There's no getters for the fields, and there is also the fields are private, so we will need getters. Getter. Now it should work. So if you remember, I'll show you in the documentation real quick. Okay, it says process finished. I'll just print the student out so you can see what I'm doing. No, it was able to read that student from the file. So if you look here in the specification of Jackson, you can see that it requires getter method. Serialization, by the way, it means that Actually, I even forgot. I think serialization is getting it from file to an object. So we need getter methods for it. So the reason we need getter methods is so it can see which fields we have in our class. But yeah, that's how mapping works basically. Let's see what else I'm supposed to do. Okay, that's JSON basics. Object mapper, we've done it. Hmm. Array. Okay, so that's one object in JSON. What if we want to have more than one object in the JSON? We want to have, for example, three students. So as you remember, in JSON, an array is denoted by square brackets. So we just contain the whole thing in square brackets. And then we can add more students. We can have another student. I'll just copy this real quick. Okay, student name, Prakash. And another student, which is the three. GPA of 6. So we have three students in an array now. And you can see that the input given to us in the exam will be in the same format. So it's an array of objects. So you can see square brackets, it's an array, and each object is in curly braces. So we just write it. Now we have three student objects. Now there's a small change. What if we want to have, so in the class we have an array of student objects. If we want to store it, we will need to make the variable a student array as well. And here, when we pass in the class, now it is no longer just one student. We will have to pass student array, and then to pass this in as a class, we do the class, and everything else should go just fine. We can just use a for each loop to print it. We print every single student in the array. Yep, it works. So now, two more things. The third thing is, what if the student has an array field? For example, it has a private integer array of subjects. Each subject has an ID, right? For example, this could be like subject ID number 23, 21, 12, 54, 122, like that. So what if it has an array? So like I said, in JSON, there can be multiple objects inside an array, and there can also be arrays inside an object. So since they have subjects, we just put subjects, and it just becomes an array. Is there any difference between having a field array or set? Sets are different. Set is a whole different data type in Java. Array is array is a primitive type. It's just simple. We'll actually discuss sets later when we start doing queries. But for now, a simple difference between array and set is that set is an implementation of the list interface, and the unique identifier of a set is that it does not have repetitions. A set cannot have two same members, and also a set does not have any specific order unless I think you're using a tree set. So yes, as far as JSON is concerned, there's no sets in JSON. just has arrays. So subjects 12. I actually think I should be writing this in double quotes, but let's see. I'll just use the same subjects for all of them because I'm lazy. Now it should work just like usual. Yep, as you can see, it works. Even though that's a nested array, it works. And you can see even here in the exam, minifigures is an array here. So it's an array with multiple minifigure objects inside it. So yeah, one last thing as far as JSON is concerned is the at JSON property thing. So suppose in our public class student, we have an enum. So first let me create an enum. This enum represents the aptitude of the student. So private, no, let's make it public. Why not? In the exam, it always says public static nested. Public static enum aptitude. So a student can be either of these values. Either the student is a dumbass, or the student is all right, or the student is smart. This enum has three values. And what if you want these values to be automatically, you know how we use an enum constructor in the feedback tests? But when it comes to JSON, there's something similar. It's called JSON property. So suppose in JSON, we've written, by the way, I don't think these attributes have to be in any specific order. I think you can just put Neptune above the name and it should still work. Let me try it. See, in JSON, as long as you have that field, it doesn't matter what order it's in. It just has to have the same name. Anyway, suppose we put here aptitude and we want to put domains. And even though it's not in all caps, we want it to map to this enum value. And same as okay. This is actually important because this enum stuff you will have to write it in the class, especially if you didn't do so well on your feedback tests. Okay. So what if you want it to map automatically? There's this Lombok. I think no, this isn't Lombok. This is Jackson. It's called JSON property. So you write JSON property right on top of that property, and you pass in the parameter of what you want it to map from with the mass. All right. Smart. Now this should work. We'll create a new field of type aptitude, okay? And you can see it should correctly map the aptitudes as well. Yeah. Aptitude, you can see that it's in full caps, which means it mapped to the enum value and it's not just repeating what it read here. So the JSON mapping was successful. Let me read the, mm, okay, we have done JSON property. Okay, we've done the basics. We basically done until like C1. Now we have to do, well, no, not finished C1. Generics. Let me see how much time I have till the meeting ends. Can someone see how long this meeting's been going on for? So I can estimate how much time I have. You know what? I'll explain generics anyway. Let's risk it. Generics. Good old generics. Okay, in a class. Suppose we have a class called printer, right? And all it does, it has a field. Let's just say text. It has a field called text, and its only purpose is to print stuff. It takes something and it prints it. Just for to be fast, I'll have an OLargs constructor. So it has text and it has only one method, which is public void load, and it prints its field. So text. That's all it does. We go to main. Just delete it all. We create a new printer. Printer is equal to new printer. Let's just give it some text. Hello. And then we go printer dot print. And all it does is it prints. So let's check it out. Hello. Now, right now, printer only works with strings. You have to give it a string and it prints out a string. If you give it, let's say 25, it's not going to work. It's going to say it's the wrong type. Say incompatible types. Int cannot be converted into java.length.string. What if you want this printer to work with anything, to basically print the string representation of anything? What if literally we have a student, right? Uh, well, I don't want to create a whole new student. Just, you want it to work with anything. This is called a generic in Java. If you want a class to work with more than one type, you use this. I'm sure you've seen these angle brackets in a lot of places. So this allows you, you know how functions, if you have a parameter to a function, if you have like a string value, you can use that value anywhere like this, stuff like this. You can use that value anywhere in the method. What a generic allows you to do is take a type as a parameter. So normally we just go T. With generics, the naming convention goes like T, U, V, X, Y, Z. But yeah, T, we're only taking one parameter right now. So now what this lets you do is use it in places of types. So text, right? It can be of any type. So instead of string, we do T, private T text. And by the way, it doesn't always have to be T. You can just do uh, my type, private, my type text. And here, if you want to print it, you can just print text. Now you go main and you can pass in 25. It should still print 25. Yep, it prints 25. What if you give it a student? Okay, for is saying for the nested class, the student uses private for the instances, even though the question didn't mention it. The question said that the class should be final, including all the common attributes. So the professor automatically put all the fields as final, and we're just going to do the same. Because the class has getters, it doesn't matter if you make the field private or not. I mean, if he mentions that you need to make it private, then yeah. Otherwise, just to be safe, you have getters anyway, just make them private. Okay, I'm gonna make the enum private just so I can test, like I'll make a simple student. So I made a simple student. And because this works with literally any type, by the way, because of convention, I'm just gonna put T instead of my type. So because it works with anything, we can literally just pass in the student. And by the way, a student is of type student. So instead of T, you could literally just put private student text. So it's of type student. You can also do this new printer of type student. Yeah. But it says it's not necessary. So instead here we put student, and if we print it, it will just print the string representation of the student. Fahad, Neptune, GPA. Yeah, Ricardo, it's immutable. I guess final does that mean that, right? It's read only. Read only and immutable is the same thing. But yeah, this is the basics of generics. You can pass in types as a parameter. And just to give an example of a generic, we can see here in the interface it gives us public interface queries TUV extends enum. So we need three types as the parameter here. T, it says the type of your entity, first class. U, the type of your nested class, second class. And V, the type of your enum class. And V extends enum just means that it is something. Okay, so you know what enums are in Java? An enum is basically a class behind the scenes. Like here, this could have just been an enum. We can do enum printer, or it could have just been a class printer extends enum. Yeah, there is a big class in Java called enum, and all the enums with a small e in Java are basically extending that class. So that's why the professor, because he's expecting us to give an enum, he says v extends enum. All this means is that your third type has to be an enum object. So T will be the type of my entity. We just pass it in. U, the type of my nested class, and V, the type of my enum. Now let me just see if I'm sharing the screen. Okay, I still have 10 minutes before this meeting ends. Let me just open T2. Okay, so here's the solution of C2 by the professor. Here's the base class, queries.java and repository.java. So as you remember before, an abstract class is a class that cannot be instantiated, which means you cannot create an instance of an abstract class. You can only extend it. So he will provide a base class, and you can see here it's a generic class. So it takes a parameter t, which is the type of the entity. Entity is just the class you're using. So they have a abstract class repository. What is the use of an abstract class? It's basically it gives some base behavior that you can reuse later. So an abstract class could be car, which has the behavior start, drive, refuel, stuff like that. So it describes that behavior, and then later on you can extend it and reuse that behavior. So, see, like I said in the group, generics are a complex topic. So I'm just going to explain it in the context of the exam. He will give an abstract class repository. Just remember that a class, right? If you have a class and you're dealing with another class, then you extend it. So you can do class plus class. It means you extend it. Class plus interface means you implement it. So it doesn't matter that it's an abstract class, you extend it. So what this class basically does is it reads through the file data.json and it just creates this list entities. It has its own member entities and it has a function, it has a method getAll and toString. So suppose in this case we are doing Lego sets, right? So what this does is it goes through the Lego, this data. This is a bunch of Lego sets. If you know from the JSON, this is a bunch of Lego sets. So it goes through this file and it loads, it has a list of all the Lego sets. This dot entities is all the Lego sets in the file. Like it's a bunch of Lego set objects. You can see in his implementation. Implementation, I'll do it in the next video. But you can see in the implementation, it says extends repository, Lego set, implements, queries, Lego set minifigure, Lego set theme. So yeah, that's it. It just passes in the type Lego set and it has the entities, which is all the Lego sets. Now, what you will be using is the get all method of this repository. What get all does is it returns an array list of all the Lego set objects in this repository, in this JSON file. By the way, repository in real life, like in real life programming, is just another word for database. Repository is basically just database. So get all will just get a list of all the Lego sets in the database. Now in the next video, we will do the Lego set class because some people, they fail the feedback test. So they need to know how to do the Lego set class. And the next, then we will implement the repository and do the queries. We'll go through all of the queries in one meeting. So yeah, for now, I'll end this meeting if there's no questions about, basic generics. Because I just woke up, I might be missing something. No questions? Okay, great. Let me just read through again. Yeah, get all is the only thing that's relevant. Okay, I'll see you guys in the next meeting.